Hello everyone, this is Rashida. Welcome to my channel. Today we are going to talk about CountVectorizer. What is CountVectorizer? Well, you know that we cannot use text data in our machine learning models. Now, what if you have text data as a column, like maybe the comments or the review people wrote? Say you have to use one text column like that to the machine learning. In that case, we need to convert the text data to the numeric data, and there are multiple methods to do that, and CountVectorizer is just one of them. So today we are going to learn how to use CountVectorizer to convert the text data to the numeric data. To begin with, I will just do the necessary imports. Import pandas as PD, and then from sklearn.featureextraction.text import CountVectorizer. That's our method. So here I just created a piece of text. Hello everyone, this is Lily. My aunt's name is also Lily. I love my aunt and I'm trying to learn how to use CountVectorizer. That's the text we are going to convert as the numeric data. First we call the CountVectorizer method and save it in this variable called CV. And then simply we fit transform this text data into CV. After that, I want to convert this count matrix for the fit transform the text, this count matrix to array. So we have this array of numbers. Okay, so what are these numbers? Okay, we'll talk about it soon. First, what I want to do is I want to just convert these numbers to a data frame, pd.dataframe. So data is this array, and then columns is cv, this cv.get feature names. Okay, if we do that, you get the column names as each word we have, and then these numbers. So what are these numbers? These numbers are the frequency of each word occurring. Look, we have also only once, so it's 1. Then we have aunt twice, so it's 2. Look, aunt and aunt, we have it twice. So we have is also twice, so the value of is also 2. So this is that simple. And let's see what else we can do with CountVectorizer. There are a lot of other parameters that we can use to really make it efficient. In this text here, the whole text is one string. Now I'm just breaking them up. Each sentence, I'm making them as one string and then comma. So hello everyone, this is Lily, that's one string, comma. My aunt's name is also Lily, that's another string, comma. I love my aunt, comma. And finally this last line. So we follow the same procedure again, cv CountVectorizer, cv.fit transform, then we feed this text to it, convert this to array, and we get this. For each string, we get one individual array or list. Now when we convert this array to a data frame, this is what we get. We get 4 rows for 4 lists here or 4 strings here. So what happens this time? Look, this also comes in the second string, right? So it goes, the 1 goes in the second row, but for the first row, it's 0, right? There is no also the first row, so it's 0. And there is also no also for the third and fourth row as well, so they're also zeros. So I love my aunt and these 2 strings, we do not have any also. So they are also zeros. Same as M. There is only one M that is in the last line, right? I am trying this M. There is no other M here in this first tree. So they are all zeros. So you get the idea how we convert the data frame. Now notice one thing, CountVectorizer method converts all the words smaller case by default. Okay, you can see that all of them are smaller case, but some of them are actually uppercase, but it already converted it by default. If you don't want this, you can pass lowercase equals to false, into this CountVectorizer method and follow the exact same procedure, and you see how the data frame becomes. You see my, when it's uppercase, it's 1, and when it's lowercase, it's another feature. So now you need to decide if you need this lowercase false parameter. Now look, only for these 4 lines of strings, we got this big data frame, right? These many columns. Now we need to think that if we really need these many features, are all the features really important? Now say I do not want this is, to, and am, okay? These words here, maybe these are not really too significant words for me. So I can exclude them. So just stop words equals to am, is, and to. I pass this in CountVectorizer and then follow the same procedure again. And look here in the data frame, I do not have is, to, and am. Now there is default stop words list already there. So stop words English, if you just pass stop words English, it will automatically just take out all the stop words. And see, so it took out pretty much all the stop words. You can see it took out also, it took out this, my, is that, and then it just kept the very significant words here. There are other parameters you can use to reduce the number of columns or exclude the unnecessary features. Just see here I prepared another set of text. Lily is a good girl. Lily is a good student. Lily is very good in math. Lily loves coffee. She is from Brazil. So this is the set of text we have. For this one, I'm using maxdf75. So what is that? So each string is a document. If a word is coming up 75% or more of the document, then that's not very useful in the machine learning, right? So I can put maxdf equals to 0.75. You can use 0.8, 0.9, or 0.5, whatever you think appropriate for you. And then I'm also going to use stop words English, so I take out the stop words as well. So what happens, you see the Lily is, these 2 words are not here because Lily comes up pretty much every document. And is also came up in every document pretty much except for this one. So the stop words are gone. These two frequent words are also gone. So we have only the features that we really value. The other way, in the same way, you can use meandf equals to 2, these parameters as well. So what meandf does exactly the opposite. Like here I'm doing meandf equals to 2. That means if any word is coming up less than twice in less than 2 documents, then that's not important. Okay, that's what this meandf equals to 2 means. Now it depends on you what you want. You can use 2, 5, or you can use a percentage like 20% or 30%. If anything coming up less than 20% of the time, then that's not important. In that case, you have to put 0.2. But anyway, I'm using 2. And if I use 2, then this is what it looks like. Only three words came up more than twice. I'm just presenting you the options and then you can choose whatever options suitable for your project. Lastly, there is another feature I want to show you, that is max features equals to 5. And you can use 5, 10, 15 or any number. So I keep 5. Maybe you are working with a product line and people writing reviews of your products, and you have total of 10,000 reviews in one column. And now that 10,000 reviews can have 20,000 words. That means 20,000 features, 20,000 columns. So you may not want that many columns because If you want to use that much for your analytics or that much for your machine learning or deep learning, that's going to be computationally expensive and also time consuming. In that case, first of all, we take care of the stop words. After taking out the stop words, you still probably have 15,000 words. So in that case, you can choose the number of feature you want. Like maybe I would choose total of 5,000 words. I want only 5,000 words for our machine learning model. So that's what it is. So here we have a really small documents. I use max features 5 and then stop words English. And this is the data frame I left with. Only pretty small and significant features. In my next video, I want to discuss with another method to convert the text data into numeric data. And in the following video, I will show you how we can use them in a machine learning model. So please stay tuned. If you like this video, like, comment, share, and subscribe. Thank you so much for watching.